I've arrived in Oman at Muscat, the city of Muscat, and we're outside on the outskirts. We've taken a bit of a drive out of town this morning to get to this farm location. And on the way, I'm just been absolutely amazed at the dryness and the desolateness of this place. Look at the soil around me here that's been prepared for, you know, some other greenhouses to go up, but it's just dry and barren. This is really a desolate place. It's a desert country and perfect for doing aquaponics. It really, really is. So we've come here today to see a farm that's been built by one of my students, Arvind of Water Farmers. And we've seen other ones we've shared with you. You'll remember the farm in Hong Kong and a few other places where Arvind has built fantastic farms. And this is a really great one because of the environment it's in. We're going to show you a lot of stuff about the greenhouse design and why that's done and all the things that are done to enhance the building of the aquaponic system here in this dry place. Now come with me and we'll have a look inside the greenhouse. And this is the newest greenhouse, this one. The project is continually expanding, and this is the newest one. And you can see as we get in here that the beds have just been made. There's new beds here, they're on the ground, and the foam's in place, the water is circulating, and just last night the fish were placed into the system. And we've got some great shots of those fish in the new tanks, and the whole system is now cycling, getting ready to take the plants. You'll see these beautiful tomato bushes, look, them freshly planted, but what I really want to show you in this part of the greenhouse is the aeration. Have a look at this fantastic aeration that's going on here in the fish tank. You know, we talk about that quite often in the lessons, about aeration, but this is fantastic. Look at it. It's almost blowing the fish up out of the water, but not quite. You can see the vigorous aeration that's going on here, which means that everything in the system is going to be properly aerated. You're going to have healthy fish and healthy plants. See down here you can see some of the fish, but now I want to show you the filters. Okay, Arvind, now this filtration you've got here is a bit unique, and I'd like to understand exactly what you've done here. You might explain to me, because you seem to have developed an up-down filter.
Yes.
You know, you've got some K3 in here by the look of it. So what exactly is going on?
So what we do is, when we come out the fish tank, we use a radial filter or a swirl filter, regular old swirl filter, to take the solids out, deposit them. We use a settlement tank after that, and then we come into this vertical filter where we have a combination of both aeration as well as solid settlement. Okay. So we have an up-down. Use this as a solid settlement tank.
So that's a typical up-down. There's nothing strange about that, is there?
Nothing whatsoever. Just as a means to break the velocity of the flow, because we have 3 fish tanks feeding into this. Then we have the aeration, just so that, because we have a lot of settlement, there is a tendency for things to go anaerobic, just to ensure that doesn't happen.
So you want to keep it moving.
Yes, exactly. There's nothing much, there's no more use to that than anything else. It's just to make sure everything is moving, and there are more moving parts to it if we add some biofilter media into it. Okay. And from here into the sump, and off away they go. So can I just backtrack a bit? Yes. So you've got this K3 in here basically to make sure the sediment keeps moving. Exactly, correct.
It's primarily not necessarily a biofilter. You're really concerned with keeping the solid material moving. Is that what you're saying?
That is exactly what it is. It isn't much time for any biofiltration to actually happen, because it's a quick flow through. This way we have a lot of microbes that interact with the biology of the system. Definitely that part is true, but this is more just to keep things aerobic and keep things moving. A little bit of agitation always helps. So
it's really the same old thing, but you've come up with a way of compacting it?
Yes.
And making it work more efficiently?
Exactly.
So what happens here in the middle then? The water's going then out to somewhere else, is it?
Out to the sump.
Can we go and have a look at the sump?
Perfectly, let's do it.
Okay. Arvind, one of the first things I noticed when I came here was the redness of the water. Now, I know what the answer is, but I want you to tell me, why is the water so red?
2 things really. One is that we use seaweed extract that tends to give the water a black coloration. We use a concentrated powder.
You get it in a powder?
Yes. And the other one is chelated iron, because we don't get an iron content in our fish feed, and we don't have very much iron in our water either. We use chelated iron, which is an EDDHA, 6%.
Can you say that again?
EDDHA,
6%.
6% iron. And the thing is that it tends to leave behind a red pigmentation in the water. And it's by far the most stable form of iron, which does not...
Why is it stable though?
It is because that the EDDHA molecule that is chelated, that is used to chelate the iron, is a sugar molecule.
Okay.
And sugar, in the sense, it's a carbohydrate molecule.
So it breaks down very quickly.
Very quickly, yes. And we like that because it doesn't leave a residue behind in the system, unlike the EDTA.
Yeah, it leaves behind
It
stuff.
does leave
and
behind.
it becomes accumulative.
Yes,
doesn't
it does become cumulative. And these are things that you don't see visually, and so you don't tend to notice that it's a problem until you actually do the chemistry of the water and you understand that it is leaving behind a substrate. And it's also very stable at a wide range of pH. So if we're growing tomatoes,
from very low to very high, isn't it?
And we want to maintain a low pH, say around 6.4, 6.6. EDDHA is very stable at that range, whereas the others not so much.
Okay, that's good because I know some students are going to be concerned about the red
definitely,
colour.
yes.
They're going to say, oh, I can't see the fish. Is it important to see the fish?
No, not at all. People fail to understand that when they see something clean, something before that has been used to clean the system.
Yeah, or to take something out.
Yes, exactly. Either using ozone or using bleaches or using any sort of cleansing agent is actually detrimental to the whole system that we have going here in terms of pure food and pure production.
Absolutely.
Yeah.
Unfortunately, some people want their system to look like an aquarium.
Yes, they do, yes.
Yeah, and that's not really a food production system.
No, not at all.
Is it?
Yeah. We want it to be as accumulative and cumulative in its biology, its microflora and fauna as well. So we want things like algae to be present in certain quantities because they all play an important role in the whole biofertigation program that we have running in this system.
Absolutely wonderful. So, red is good.
That is good.
Thank you. Arvin, we're talking about the header tank, and it's only recently occurred to me that that's the wrong name for it.
Yes.
It's really a surge chamber, isn't it? Or a distribution chamber. When we say header tank, it tends to give people the wrong impression. They think it's some kind of storage tank. Now, for this huge system, you've got this little tiny tank.
Yes, we do.
How many litres is that?
That's about 300 litres tops.
300 litres, so that's 100 gallons.
Yes.
No, less than that, 75 gallons. So it's not very big.
Not very big.
And I notice you've got all 1 inch or 25 millimetre pipe coming out of here.
Correct.
A whole lot of them.
Yes.
So where are they going to?
They go to each line of the media beds. So we have about 11 lines of media beds there, and we have 8 lines of rafts connected to this overhead tank.
All being supplied by here?
All being supplied by there.
Yeah.
The misconception that is the overhead tank is that we use this overhead tank simply to act as a buffer between the pump and the delivery point.
Okay.
So all it does, it stores water at a higher potential energy, transfers the potential energy into kinetic energy when we get the water flows on the other ends. So all it doesn't store water in there for more than 2 seconds at most.
So if the pump stops, it'll quickly be empty anyway.
Yeah, exactly. Yeah.
So it's not a storage facility.
Not a storage facility.
So this 25 millimetre and 1 inch pipe we see here, there's no valves on them. Where are the valves?
The valves are on the other end, so we can actually monitor and meter each bed individually.
So every single bed you can regulate the flow from this?
Yes. It beats having to run back and tracing that pipe and then adjusting the valve and having someone shout across whether it's worked or not.
Well, it's much better to control at the point, isn't it?
Definitely.
So now another point you were talking to me earlier about the size of the pump and the capacity of the pump in relation to this. Rather than trying to store a whole pile of water up there, you're better off to move it through quickly, aren't you?
Exactly. It makes for better energy usage if we actually push water faster than try to push it higher up. Because the head gives a lot of loss, and pushing water higher up into higher overhead tanks or bigger overhead tanks is a lot more tougher than actually trying to push it up a certain height and trying to push it faster out. So flow rate's a better way to go in energy-wise.
So if we're going to be silly about it, we could put this up at 6 metres up.
60 for all you can.
Yeah, and it's not right. So here we're at about 1.7 metres.
Exactly,
1.6 metres. And it's not a very big tank, and it's working well. And of course we can see there's a big overflow pipe here.
That's the pumping that's going back into the...
So what if it overflows? What's going to happen?
We generally have water not exceeding this point, so there's no reason for overflow.
Excellent. Well, thanks for explaining that.
Pleasure.
It's great. Arvin, how many autosiphons have you got in this farm?
We have 300 autosiphons.
300?
Yes.
We often have people say, oh, autosiphons don't work, they're only for home systems. But here you've got 300 of them.
Yes.
Here we've got a typical example of one. Can I pull that out?
Yes, please, go ahead.
Yeah, so there's the bell.
Yes. And you
upstand.
Upstand pipe.
And we've got the
gravel
guard, whatever you want to call it. So simplicity itself.
Yes.
And so you've got 300 of them.
Yes.
I noticed that you're making all the beds fairly short, about 2.5 metres.
Yes. 2 meters actually.
2 metres, are
2
they?
meters by half a meter wide.
And here we see the water coming in.
Yes.
This is for this bed up here, and this bed's got it down this end.
Right down there.
And we can probably see in the camera, each one has its own little regulator.
It does, yes.
So we can come along and regulate the flow,
Yes.
just as we would in a home system.
Exactly.
It's no
Exactly.
different.
Yes.
But here we've got a big farm,
An acre big.
an acre of farm, and we're using auto siphons. And
Yes.
why do you use auto siphons?
Because they're the simplest thing and they're fail-safe. Anything electronic or anything mechanical that is dependent on other factors, I cannot deal with the variables that come with that. Because we have only 5 people running this acre-sized farm, like we
5
talked
people
with,
running
5
the farm?
people.
Yeah.
So it becomes all the more important that these things sort of take care of themselves.
Yeah.
And auto siphons, if you can, it's not rocket science.
Yeah.
If you can just tune it well enough with the intake and the outflow, it works like a
Yeah,
song.
because there's no moving parts.
Yes.
There's nothing to wear out.
Nothing to wear out.
The only thing that can go wrong is sometimes you can get some roots grow down in
Yes,
there.
yes.
So a bit of general maintenance, the same as we do for a small home system.
Exactly,
Yeah.
exactly. And a little bit of work around the farm never hurts.
Yeah, that's right. So we see again the same principle, don't we? That what we've done with the farm really is just expand the same principles
Yes.
that we use at all levels.
Exactly.
Obviously we make things a bit bigger. Our plumbing might be slightly different, but the principles are the same.
Principles are very much the same.
Aren't they? Yeah. Sorry, before we leave this spot, I want to ask you really, why are the beds so narrow? Why have you made them so narrow?
It's ease of operation. Operations like pollination, harvesting, planting, etc., even pruning become so much easier because there's just 2 rows of plants that will be accessed from a walkway when you're standing in here, and on either side you'll have each one plant to operate over.
So
that
we're
way-
actually going to plant in here your long-term plants, like
Yes.
tomatoes.
Yes.
We're not going to plant lettuce in here.
No, by far not.
Yeah. So once again, the rule applies, doesn't it?
Yes.
Long-term, mostly fruiting plants
Mostly fruiting
will
and
be in
flowering.
the media beds.
Yes.
And then in the raft beds, we'll have the,
All the greens.
rapid growing greens. So there we go. Same thing, isn't it? As we would do at home.
Yes,
The same thing.
exactly, yeah. And we also have one person walking through, so it's easy for one person to monitor when
They
he
can
has
work
exactly
both
one
sides.
thing to look at. Yeah,
Easy enough.
Yeah.
And I imagine you've got a trolley,
trolley
a
that
work trolley.
goes right through. Yeah,
Yep. Excellent. How good is that?
works like a song.
It does. Okay, Arvind. Now, one thing that fascinates me about what you've done here is the height of the roof.
Yes.
Now, why have you done that?
Simply because it gets very hot here in the summers. It goes up to 55 degrees Celsius.
55
Yes,
Celsius.
Yes.
Wow.
And we're farther out the city and farther out from the coast, so we tend to get the heat from the hills as well. So this area in essence holds a lot of heat. It retains a lot of heat. So it becomes important for us to push air out naturally.
Okay.
Without a whole lot of mechanization, because we're all about reduced carbon footprint and we're about organic and we're about keeping things close to nature. So we like to keep it as close to nature as possible.
So how high is it here in the middle?
It's about 8 meters tall.
8 meters high.
Yes.
And I can see there's quite a bit of venting goes on there, so
Correct.
the hot air will get out. So if we were to take a temperature gauge, we'd find that it gets much hotter as the higher you go.
Hotter very quick as well.
So right here at ground level,
We're pleasant
so
right now.
if it's 55 degrees, let's
Yes.
say it's a 55 degree day, what kind of air temperature could I expect to have here?
You could get as low as 45.
45.
So that's a 10-degree drop.
That's a 10 degree drop.
Yes.
It's still pretty darn hot
Yes,
though.
yes,
Yeah.
yes.
So what kind of water temperature we have on that day?
The highest we've ever recorded is about 36.
Okay.
That's about a day or two during the peak of the summer. But usually we maintain a temperature of say 32, 33.
Okay, so how do you get around that with your plants?
We obviously we won't be growing lettuce in the peak of the summer. That's the peak of 3 months. So we have crops. There are some pak choi varieties that do well in the heat. There's a spinach variety that does well in the heat. There's basil. The herbs they like the heat
Yeah.
and they like the cold roots with the ambient heat.
Okay.
So we try to grow them during
So
the
that's
summer.
being a clever farmer, isn't it, really?
Yes, yes.
So I notice here, over the top of the fish tanks, you have a lower roof.
Yes.
Why is that?
The reason for that is we want to keep the shade on the fish tanks, so the fish tanks don't heat up,
Okay.
because technically the fish tank is the only surface of water that is directly exposed to the
Yeah, because the rest are
external
covered with
elements.
foam and plants, aren't
Yes,
they?
exactly. And even the media beds, the top 2 inches is free of water, so the water never comes into contact with direct sunlight anywhere other than the fish tank. So we want to keep the fish tank completely shaded in the summer to
All
keep
through the
things
summer.
going. Yes.
So that's solid roof,
Yes.
whereas this is kind of translucent, isn't it?
It is, yes. It's
So
a
we do-
50% shade.
So we get a lot of nice light to the
Diffuse light,
plants,
yes.
to the diffuse light to the plant. So that's pretty clever, really. And the other factor too, when we were talking earlier, is that your pipes are buried underground,
Yes, yes.
wherever possible.
Yes.
How far underground? Just below the surface?
A meter down.
A metre down.
Yes.
So that's going to help a lot too, isn't it?
Yes, it does.
Do you have any idea what the soil temperature is a metre down?
The soil outside, the soil temperature would be at least 5 to 6 degrees lesser, a meter down.
A metre down.
Yes.
So that's another factor that helps you keep
Yes.
the water temperature down, isn't it?
Yes.
And this is all done without need for coolers or
No,
special fans
No
or
fans, yeah.
anything like that. So earlier when we were talking about this, right on the edge there, I could feel the breeze coming in underneath the edge of this. Well, it's not really shade cloth, is it? Is it shade cloth?
It's a kind of shade net, yes.
Yeah, yeah. So I could actually feel the cool air coming in from the bottom. So it really does work.
Yes, it does work.
See, once again, simplicity, but extremely clever.
Yes.